All right, you little squirrels. One of the skills we're going to be using a lot this quarter, normally we'd go through it together, but obviously circumstances change, is called dimensional analysis. I know that sounds really, really scary, but it's really just a way of organizing complex problems and is a very efficient skill that will help you really clean up your problems and think at a lot higher level. Like I said, it sounds scary, but I think you guys will get the hang of it pretty quick here. What it really boils down to is something called a unit conversion factor, sometimes UCF. And the key idea about this is that the two values we use in dimensional analysis have to be equivalent. What I mean by that is, let's just say we have a problem on a test where someone's going to run a 5,000-meter race and they want to know how many miles that is. This right here is an example of what a unit conversion factor is. And what this really means is that we're going to convert between different units. And the important part is that if I go run 1 mile and somebody else goes and runs 1,609 meters, we will run exactly the same distance. These two things are equivalent, which is how I can convert them. So the key idea here is that just like in math, when you have a top and a bottom cancel out, it's the same idea because anything divided by itself cancels out to 1. So here we have meters divided by meters. What will happen is if we take 5,000 divided by 1,609, the meter conversions cancel out here, and the answer will be given to us in miles because that's the only unit that's left. That answer would come out to be 3.10, and then again, since meters and meters canceled out, that answer is 3.10 miles. Just another example here. If you were given the problem, how many seconds are in 5.5 years, I know you could all get a calculator and kind of just rip through that, but you're going to get kind of messy, you're going to lose track of stuff along the way. Dimensional analysis is a way for us to organize that, and what you'll always do is start with what you're given. So here we're given 5.5 years, which is what I'm going to start with. When I'm all done, I want to get to seconds, and that's really what we have to think about along the way is what am I trying to get to? What is the problem asking me to solve for? So in order to begin this, we first start off and we think, well, I'm going to start with years. I know I want to cancel out years, so what we can go do is put, well, I want years down here, because then years and years will cancel out. And if I'm going to put something right here in this unit conversion factor, it has to work for me. And I know that 1 year and 365 days are equivalent values, so I'm allowed to do that. What ends up happening then is our years and years cancel out, and right now, if we took 5.5 times 365, that would give us how many days are in 5.5 years, but I got to keep going because I want seconds. So I have to get rid of days then, so I go put days on the bottom, and I know that 1 day is equivalent to 24 hours, and those two values are going to cancel out. So now if I took 5.5 times 365 times 24, that would give me how many hours there are because all my other units have canceled out. But I don't want hours, I want seconds. So I have to keep going. I need to cancel out hours. I'm going to put hours on bottom, and I know that in 1 hour, that's equivalent to 60 minutes. So I can put those two things there. Hours and hours will cancel out, and now if I did all this multiplication, because it's on top, it's multiplying, on bottom it'd be dividing, now I'd be in minutes, so I know that I'm getting pretty close here, and now I need to cancel out minutes. So what I do is I see that minutes and minutes will cancel out, and that 60 seconds is equivalent to 1 minute, and then minutes divided by minutes will cancel. I'll be left with just seconds. So whatever this times this times this times this times this is will give me how many seconds there are. That answer comes out to be 1.73 times 10 to the 8th, which is a really, really big number, which makes sense because in 5 years there's going to be a lot of seconds. So that highlights what's called dimensional analysis using unit conversion factors where we cancel along the way and think about what are we given and what do we want to get to in that problem. You'll use this for your moles.